We're going to be talking about fasteners that we would typically see in finished carpentry and some that would also fall into the architecture and construction career cluster that we should be familiar with. The first thing we're going to talk about is some of our nails. And the first one we're going to look at is one of the smaller nails that we would see. And this is called a brad nail or a wire brad. And this is a pretty small nail, generally not very long, probably 2 inches or less. And they're probably going to bend pretty easy on you as you're nailing them in. So you got to be careful with these ones that they don't bend over. The next one we would see a lot more of in trimming houses and things like that. It's going to be a finishing nail, a little bit bigger diameter. It's got a head that is just about the same size as the shank, just a little bit bigger so that that head can hold down the workpiece as it's nailed in. The next one here, we notice this is a big sinker that we'd be using for framing a house. This particular one has this gold colored coating on it, and this is a vinyl coating on the nail. This is a coated sinker. This next one, you notice all of these little rings or barbs around here. As it gets driven in, these are going to bend backwards towards the head, kind of creating these barbs that are going to prevent the nail from coming loose as it's holding in the workpiece. So things like maybe a pole barn or something like that, as it's getting built and it's blowing around in the wind, these barbs are going to help keep these nails in place so that they don't work themselves loose. And it's called a ring shank nail. This next one has a little different coating on it, and this one looks a little tarnished, but it's usually kind of a silver coating. It's a lot more shiny usually, or different looking than our other nails. This particular nail has a big head on it, and this particular nail is called a roofing nail. The big head helps hold down asphalt shingles and disperses more of the pressure around that soft asphalt material. So as the wind blows and things of that nature, it doesn't rip through the shingle because of that big head. Its shiny coating is a galvanized coating. There's different ways that they galvanize fasteners. There could be a hot dip or it could be electroplated, but the galvanization helps with weather resistance. Over time, it's going to be exposed to rain and snow and things like that. This is going to help slow down the decay so it doesn't rust out and your shingles don't go flying off. This next one here, a little different. It's got two different heads on there. This is called a duplex nail. And you would use this in situations where you want to temporarily fasten things together. You could nail them nice and secure with that head, and it's going to pull your workpiece tight to whatever you're nailing. And then later you could come back with your hammer and pull against that second head to remove that nail from whatever it's driven into. So the duplex nail is really nice if you know you have to remove that fastener later on. Maybe you're putting up some forms that need to be taken down later. Maybe you're just bracing some walls and you know you're going to have to pull those nails out. Those would be situations where that duplex nail would be really convenient. So when we nail, one thing that we want to prevent is the hammerhead, especially in finished carpentry. We want to prevent the hammerhead from hitting the surface of the wood. So if we were to hit the surface of the wood with a hammer, we kind of have a recess here that would damage our wood. And so a couple ways we can get around that. One is by using a nail set. On a small nail like a finish nail, you have this dimple. Then this nail set with the fine pointed nail set, you can fit that in that dimple and drive that down. Bigger heads, you could use a bigger nail set. Usually nail sets come in 3 different sizes. And you could use a bigger nail set to drive down bigger nails. You could also use a bigger nail set over this nail. And instead of sitting down in this dimple, the nail set would kind of go over the whole nail and drive that down. The bigger nail set over that smaller nail is going to create a bigger hole next to your or over top of your nail head. But some of the problems we have with this smaller nail set on the dimple is sometimes the nail set will slip out of here. And so as you're driving this down, and that nail set will slip and you'll damage the surface of your wood with an extra little hole that doesn't necessarily make the project look aesthetically pleasing. Another option we have for nail holes is we can fill them with wood filler. And you can see these have been set below, probably with a nail set or maybe with the nail gun. And these have filler in them. And you can see that the nail hole is still visible, It doesn't totally eliminate the nail hole, but we at least don't see a shiny nail sticking out of these nail holes. So the wood filler does help blend that fastener a little bit better, but doesn't totally eliminate it. Another option to help hide our fasteners is you could peel back a layer of wood, and maybe you do this with a chisel and you kind of hammer a chisel in and peel back a splinter of wood. You could drive your nail into the wood, and then when you're done, you come back with a little bit of wood glue in that area and then hold down or tape that down while it dries. And this would allow you to hide your fasteners a little bit more concealed than you would with like a nail set and wood filler, because you're not going to have a hole to fill with this. So pneumatic nails, when we talk about pneumatic tools, that typically is our air powered tools, our nail guns that hook up to a compressed air. And we have a couple different ones we'll see in the finished carpentry area or in cabinet making, and that would be brad nails. And they're typically 18 gauge nails. They're just kind of a thin wire that has a head on here. If we take a closer look, you can actually see the head along the top ridge of these. They come in a strip like this, typically, attached together. And as the nail drives one in, the next one slides forward. This would be used a lot in place of that finish nail that we originally talked about when you're trimming out a house or putting baseboard trim, chair rail, things like that. The brad nail is a good choice for installing those. Another pneumatic nail we have is called a pin nail. It's 23 gauge. It's very thin. If you take a look at it, you'll see no head on this. And if we look up closer again, you can see no head. It's just a piece of wire that would shoot into your workpiece and just hold it in place. Now, generally speaking, we don't use the pin nailer unless we're going to have a problem, like we have a really thin piece of trim or our trim is really small and the brad nails would break it. So there are times when we make really small or thin trim and the brad nails would crack or split the wood, then we would move over to the pin nailer. And the pin nailer is going to have some disadvantages. There's no head to keep it in place. So the only thing really keeping it in place is just the angle of the nail into the workpiece, because if you pull straight back, it would pull right off of that end of that nail. So some other pneumatic fasteners that we would see, narrow crown stapler. This is different than the staple gun that you would use to go around and staple plastic sheeting up, or you would use to, nail insulation in. This is going to be a more powerful nail gun. And you can see here, this narrow crown, I think it's about 3/8 of an inch, maybe a ½ inch narrow crown, has these two spikes that would come out. So instead of getting just one singular puncture like with a nail, the staple is going to have a little bit more holding force because it has two spikes going in. And then they're also connected on the top with this U shape or the crown of the staple. Now, these work really well to hold better, and they're going to be better used when you don't see this fastener. For example, if you have a place where you can hide the staple, then that would be where you'd want to use it. So we can see in this picture here that the staple on the right side has created a much bigger hole than the nail on the left side. So this was shot in with a brad nailer, and this one was shot in with a narrow crown stapler. And you can see that is a lot more area that you have to try to fix once this fastener is put in place. So the narrow crown stapler, again, if you can put it somewhere that it's not going to be seen, because it will damage the surface of the wood a little bit more than the nail. Another option for pneumatic nailers in here, these can be driven in by hand or a nail gun if you have the nail gun to do this, but it's a corrugated fastener. You can see it's kind of a wavy snake looking fastener. What that is used for a lot of times is frames. As we're building frames of some kind, you could put this across the miter joint and it's going to lock in because of those corrugations or those waviness. It's going to prevent them from pulling apart and separating. So this one is nailed in. We have a nail gun in here that will shoot those corrugated fasteners in place. Now we're going to start talking about our screws when it relates to fasteners. And these are two different screws that we're taking a look at. The top one is going to be our coarse thread. The bottom one is our fine thread. And as we look at these side by side, you can see the fine thread has a lot more twist to it than the coarse thread. The coarse thread are separated, they're further away. They're also a little bit larger blades or spirals going down there. They stick off of the shank of the screw a lot further than or the fine ones. Now, when we talk about screws, generally speaking, coarse threads like the one above is going to be used for your softwood materials. That's going to be your firs, your pines, your cedars, things like that, construction type material. The fine threads are going to be better for cabinet grade type material like oak, maple, walnut, cherry, any of those hardwoods. The fine threads are going to be better. As you're driving these in, the coarse threads are going to take less turns to get in because there's less threads. The fine threads, you're going to have to take more rotations to get that to drive in because the threads are closer together. As we talk about different heads of drives and screws, we're going to start with the shapes of the head. And this one is going to be our tapered head. This is kind of your standard screw. And as we look at that, it's flat on top and it's got this taper on bottom. So what is that taper going to do for us? It's going to allow us, as we hit the surface of the material, to kind of sink down a little bit further to try to get that head at or below the surface. So that taper kind of allows the screw to keep going once it gets to the surface of the wood. This one here is called an oval head, and you can see that it's kind of got this taper shape to the bottom still, but the top is kind of circular on top. So it's kind of got a dome on top, and the bottom still has that taper. This is going to be one as you drive in, maybe you want it to sink down a little bit, but then yet maybe you still want a little bit of fastener exposed, and this is kind of going to give it, the wood would sit right about here where the surface of the material is. So you would still have some exposed fastener on the outside of the project. The other head we're going to look at here is referred to as a pan head. Now, some people might argue that this one is more of a pan head and this is a washer head. You can kind of see it's got that extra lip around there. For the purposes of this class, you can refer to it, if it has a flat bottom, that's what we're going to refer to as our pan head. And that's going to allow this fastener, when it hits the workpiece, that it's going to want to stop. Instead of driving in a little bit further, it's going to want to stop at this surface. And one place we use that a lot is our pocket screws. When we're driving in our pocket screws, we want this to stop on this shoulder up here and not drive in further. If we were using a tapered screw, as we were to tighten this up and these two were to join together, that screw would want to sink down in here. The further it sinks down in, the weaker this material is going to be, and then that screw could be no longer holding that workpiece in place. So we want it to stop when it hits the bottom of that hole instead of continuing on. So those would be the heads that we should be familiar with: oval, tapered, and pan head. And now we're going to talk about the drives on top of the screw. This one that makes a plus or an X, depending on how you look at it, that's one of the standard screws. That's going to be a Phillips head. Okay, you see that one quite often as you go around your daily life looking at different fasteners, different things that are held together. You would see a Phillips head quite often. The next one here has just a slot. It looks like a minus. Now, if we talk about this one, it has three acceptable names that it could go by. It could be a flat head, a regular head, or a standard head screw. Either one of those names is sufficient. The next one here, if we look at it, very easy to identify. It just has that box right there in the middle. That's going to be our square drive head. This one here is a six-sided star. These two have a lot of surface area for that bit to connect with as it's driving in. Now, these ones typically have a flat, straight up and down wall to them. As you're driving in, these are straight up and down. Where the Phillips one is kind of tapered. Usually it kind of comes down to a point in the middle. So the Phillips driver typically is pointed as well. And so that's what causes it to kind of slip is, yes, there's quite a bit of surface area here, but as it goes down inside, it's tapered and it wants to pop out as you spin. Where these are flat walled inside here, and as that spins around, they just have more connecting point with the bit and it doesn't slip out as much. So these four screws are ones that you often see when you're looking at things in the construction, architecture, and construction world. Some other ones we're going to take a look at here. This is kind of a combination head. It's got our slot cut in there with our Phillips. One nice thing about these is you're driving these in. If you strip it out while you're driving it in and you need to back it up, you can always take a flat blade screwdriver and back that out, and even if your Phillips ones are damaged. If you remember from class, though, those regular standard heads like that are difficult to get out with a screwdriver. They're kind of a pain. They're slow and tedious. They're not as fast as the Phillips. Your bit wants to slip out of that groove more. Another hybrid that we have here is a Phillips square head. So this one can take a Phillips bit or a square. The same square bit that would drive this in, the number 2 square head, would also drive this in. It would fit right in here. Two more here are our hex heads. One is going to be our external hex, like a bolt head that has that hex shape. The other one is going to be more of an internal hex. And this is where you would use hex keys, sometimes referred to as Allen wrenches. Allen wrenches are a brand name though, but a hex key would fit into this internal hex and allow you to back that out, where this bolt head would take something like a socket or a wrench to get onto to tighten that down. So as we look at our different kinds of screws, the first one we're going to look at here is just our standard drywall screw, typically black like this. They're not very dense. I would not use this for anything structural. Like if you were building something, let's say a tree stand out in the woods to hunt in, you wouldn't want to use this to attach your boards to the tree and to make your frame, because they're really not as dense as some of the other screws. For example, this gold colored one here is our construction screw, and it's a lot more dense than this one. It's got more material there, more structure. So as you were putting weight on this, when you climb up in that tree stand, this is going to be a better option to hold your weight in that tree. Drywall screws really aren't structural. If there's going to be a lot of weight or force on there, then I would go to the construction screw. Our other type of screw, this is our face frame screw. It does have that pan head on there. It's got some threads. And if you notice down here at the end, it's got a little notch in the tip. That's what we're going to use for our face frame. The next one here is blue, typically identified as concrete screws. They're typically blue. Now, some people may refer to these as a Tapcon, and Tapcon is a brand of fastener. A concrete screw is coated with this blue material. It helps against corrosion because concrete is very corrosive. It's got moisture in it. It's got other chemicals. So if we were to drill into concrete with our normal drywall screw, this drywall screw would deteriorate at a lot faster rate than the concrete screw, because the concrete screw has that extra coating on there to protect it against those chemicals. The last screw we're going to look at here, you'll notice has threads all the way down. There's no taper on the end or point like there is with the rest of the screws. It's kind of a blunt edge. And this is called a machine screw. And usually something would go on the end of this, maybe a nut of some kind. A variety of things could fit on there. Now, where we see this a lot in finished carpentry would be in our cabinets when we're installing handles on our cabinets. If we're putting knobs and pulls on, this is the kind of fastener that we would see through the wood holding that knob on. Let's take a look at some of our bolts. So we've got our standard bolt, which is a hex bolt, and the bolt like this would need some kind of hole to go through, a hole in your material, a hole in a bracket or something like that, and then a nut would go on the backside. Where this leg bolt is a little different, it's got a point on there like a screw. And where I've seen a lot of these is like flat screen TV mounts. A lot of times when you're going to put that mount up, it has something like a leg bolt. If you're putting something that's going to have a lot of weight on it, you've got this thick diameter metal that's going to have more support, and you've got this long beam that's going to drive in. So when you can find a stud, the leg bolt would be a good option for mounting things, because this is going to drive into the stud and pull that fastener or other workpiece tight against what you're trying to screw to. This next one is a carriage bolt, and the carriage bolt is smooth on top, has this square kind of fitting down here at the bottom, and then has your thread. So this would allow you to put a nut on from one side and not have to have anything to hold on to the top side, because as you start pulling this tight, this square shape here is going to drive into the workpiece and not allow the head to spin. A couple places I could think of using this would be maybe a picnic table. If you're building a picnic table, you want to be able to put your plate on top of the picnic table and have a smooth surface. So you would have this, so the wood is just even with the top of this. Maybe you have just a little tiny little bulge there, and this would pull down through and then tighten to the frame of the picnic table when you're done. That would be one application. Or if you're bolting something together and you don't want somebody to access it from the outside, let's say like a barn door of some kind or a shed door, and you have hinges that are holding the door on, and you want it to be more secure. If you had this holding the door on, somebody could come along with a wrench and unbolt that. If this was on the outside of the door, somebody can't come along with a wrench and unbolt this fastener and get into your door, because there's no way to mechanically grab onto it. A couple other fasteners we have here that look similar. One is a dowel screw, and it's got nice coarse threads with points on it on each end. You would drill a hole and you could fasten two boards together, screwing them together. These threads look a lot like the leg bolt threads. A hanger bolt like this, I've seen a couple different places. One might be like this example, where you're attaching a table leg to the apron of the table, and you could use something like a wing nut or a nut on the backside to pull those tight so that that leg doesn't wiggle and wobble around. Another application where I've seen this is on the bottom of a couch, where you've got those feet that screw up into place. If you have a wood foot on the bottom of your couch, usually you would have a machine screw on top going into something like a T-nut, and then on the bottom you would have threads like this driving into that wood block. So those are examples of different bolts or fasteners you would see or could see. Now we have three different type of tips we're going to talk about when we're talking about our screws and bolts. The first one here is going to be a self-tap tip. This is going to be used like on our face frame screws as we're driving in. This is going to relieve some pressure so that the wood doesn't crack from having all this wood built up in these threads and the extra pressure in the wood. So that self-tapping tip is going to help relieve some pressure as it's driving in so it doesn't crack. Where this next one over here, this is a self-drilling. This is one that you would see on a sheet metal screw. You're going to drill through some sheet metal. This tip is actually going to do some drilling and actually create metal shavings as it's drilling in to a metal surface. And then once it gets up here to the threads, those threads would catch on that thin sheet metal. Next type over here is self-tapping. This is more of a machine screw or bolt. It's got these grooves in there, and as this starts, it's going to actually cut thread pattern into the hole that you're driving. So this is going to be probably a little bit thicker material than a thin sheet metal like this would go into. This might be like venting for your HVAC system. You're putting some of those thin sheet metal together. This might be something a little thicker that's going to have some threads cut into it, more than one or two rotations of thread, and then that's going to drive into place. So we talk about nuts on the other end of the bolt. This would be your standard hex nut. Hex nut, pretty standard. You would see this on the other end of a bolt to tighten things together. This one here would be a lock nut. This one is a nylon lock nut. It's got this nylon ring built into it. So as that thread comes and tightens up that bolt, this nylon will start cutting into those threads of the bolt as well and kind of heat up and become kind of tacky. So it doesn't vibrate loose as things are moving around and getting moved around. It won't loosen up. This one is also a lock nut, and this one has an external lock washer on it. They're attached together, and these serrated teeth, when it hits the workpiece, that's going to kind of grip the workpiece and prevent it from backing up and loosening up. Those teeth are going to keep it tight against the surface. This one here, you've probably seen one of these. This is a wing nut. This is a nut that's going to be operated by hand. So maybe something in a temporary position or something that needs to get moved a lot. Maybe you have to move a jig or something that needs to have different sizes, needs to be adjustable. That's where you would use the wing nut. Wing nut is just tightened by hand and loosened by hand. You know, you're not going to get a socket on it like you do this. If you want something super secure and it's going to be more permanent, then you're going to use one of the hex nuts. Wing nuts more temporary and adjustable. Maybe you've seen one of these. This is going to do a couple things. One, it could be for decoration, and the other could be to protect something from the threads. So it's an acorn nut or a cap nut, and this just protects the ends of the threads. So if you want to dress something up so it doesn't, you don't see the bolt sticking through, you could use this. Or maybe you have something where the bolt's sticking through and people walk by all the time, and maybe, the little threads on the bolt catch on someone's jeans or catch on someone's hand as they're walking by. A cap nut would protect those threads or protect people from those threads. This one here is called a T-nut, and the T-nut has these serration or these teeth that would dig down into the workpiece. The T-nut usually is used on the back side of a piece of wood. So you'd have the T-nut, a piece of wood, and then your bolt on the other side. And as you tighten up that bolt, this T-nut, these little spurs are going to drive deep into your workpiece, and that's going to keep it from spinning. So once they're driven in, then you can unloosen and loosen that bolt, and you don't need to have somebody or something holding on to the backside of that, like a nut. Like this one would need a nut or a wrench on the nut side and on the bolt side, where this one would just need a wrench on the bolt side because that T-nut's going to drive into the workpiece. This one here, this is called a cross dowel, and a cross dowel you see a lot in furniture that is made with like particle board and MDF. There are other applications where you could find it or use it, but for example, the cross dowel sits right here, and then a bolt would come to it and connect and pull. So as it's pulling these two pieces together, and it's pulling tight. All the pressure is in here in the middle of the wood rather than on a fastener that's close to the edge. So you can have that pulling pressure further away. Again, I've seen this a lot in like IKEA type furniture, things that you get in a package and you have to assemble yourself at home. This last one here is a square nut, and we don't see this as much in woodworking and cabinet making, architecture and construction as we used to. Used to see these all the time, but this is a square nut. You do still see them on some applications. One nice thing is that the head is kind of curve shaped, so it can fit to a radius contour, and the bottom side is usually flat. So it could fit to a little bit more radius contour than a regular hex nut that's flat. Let's take a look at some other fasteners that we might see. And so this first one here, maybe you've seen this, these little wings on here kind of compress so that they could fit through a hole. And then once they're through a hole, they can flare back open and allow you to get through. And where we would see this, and this is a toggle bolt, and where you would see this is maybe on drywall. If we're attaching cabinets or fixtures of some kind to drywall, you would drill a hole and these wings would fold up and you could push them through. Once they get through, they expand back open and you tighten this up. Now these wings are going to push against the material that you're tightening. So you can tighten this up and the sheetrock it's going to pinch between the sheetrock and hold it in place. So these are toggle bolts. This next one here is a cotter pin, and a cotter pin is generally used to keep things in place. So here's an example of a cotter pin. Maybe you have a wooden dowel, maybe you have a metal dowel or a metal pin sticking through, and that cotter pin would come through and split open, and you could bend it around to keep it in place. Maybe this needs to rotate around and needs to be able to move smoothly. And so that cotter pin would just keep that washer in place from falling off and allowing everything to move freely. This next one here is called a plastic anchor. The plastic anchor would be used for fastening screws into material that screws aren't going to hold very well in. So for example, if you're putting a screw into drywall and you're not over a stud, kind of like the toggle bolt, the plastic anchor would be a base for that screw to drive into. They also make a metal anchor. And what these two do is once they're inserted in a hole and then the screw is placed in there or the fastener is placed in there, they expand open and kind of wedge themselves into that material. So if the sheetrock is up here and it wedges open once it gets in there, it's going to allow that screw to be pulled in tight and not pull out because it's expanding open. These last one here, these are cam locks. You'd probably see these with furniture where you have to take it home and assemble it. So maybe something you got from a box store, maybe something from like IKEA, where you take it home and then you assemble it. And these cam locks would have a dowel that sticks out of a hole. So you'd have a hole where this dowel is pushed in. Then this piece of wood would slide over the dowel over here. And then this cam lock would come in and lock around the end of this head. So there's an opening on the other side we can't see. And this slowly gets bigger. It spirals around, it gets tighter. And as it tightens up, it's going to pull these two materials together. If we take a look here, you can see there's an opening, and then that spiraled kind of upward shape pulling that tight, you can kind of see in there. Okay, some drill things that we're going to talk about. These two bits here, the one on the right is called a countersink bit. It's a bit that's going to make a chamfer around a hole. So you would pre-drill a hole, and then you would use the countersink bit to create a chamfer or an angle around that hole for the screw head. This one over here on the left is a countersink bit, and it's going to do our pre-drilling all at the same time. So it's got a wider section here for the clearance hole, and then down here at the bottom it gets smaller for the pilot hole. And then the countersink here, and there's some depth to this countersink, and we'll talk about that a little bit later, why that's so long. So here's a piece of material. We've got our substrate or our base material that we're attaching another piece to. So if we have these two pieces and we're going to pull them together tight, you'll notice a couple things. The first thing is we have that countersink that we just talked about, that chamfer around a hole. We have a clearance hole or a shank hole here. This is so that the bolt can fit through there, and your bolt or screw should fit loosely in here. You should be able to wiggle your bolt back and forth through here. And then your pilot hole, if you think about a pilot of an airplane, right? They're guiding or directing the plane, they're driving the plane. Well, same with this hole. This hole is a pilot hole. It's guiding or directing that screw. So if we take a closer look here, you can see the threads are catching on the pilot hole. And then up here where the shank of the screw is no threads, you can see that there's extra material on each side. So if you had your boards with a gap in there like this, you should be able to wiggle this board freely. The threads or the shank of the screw is not catching on the workpiece here, but on the base material is where it's pulling it tight. So on the workpiece, the only thing holding this down is going to be the screw head. The head of the screw is going to pull this piece tight against the substrate or base material. So there is a difference between a counter bore and a countersink. A countersink hole has the tapered shape or the chamfer at the bottom, and that allows for a screw head to get sunk down, where a counter bore has a flat bottom and is going to have the workpiece stop. So maybe you have a washer and a bolt head. This one's a leg bolt driven in there, but maybe you have a bolt that you're assembling something with and you don't want that bolt head to sit above the workpiece. You could do a counter bore so that that bolt head would sit below the surface. Now, when we're lining up our drill bit and we want to see if our drill bit is the right size compared to a screw, this is one little trick you can do, is you can hold the drill bit over the screw, and if you can see threads on each side, then that should be an adequate size drill bit. Now, if you can see no threads, your drill bit's too big, right? If this drill bit is covering up all the threads and we can't see them, that bit is too big. If we can see the majority of the shank of the screw, the metal piece in the middle, then our drill bit is too small. So we got to find a happy medium. And usually if you use this as a general reference to see if that bit is going to be adequate for you, and you can see the threads on both sides, then that's probably an okay size drill bit to use for that hole, depending on the type of material you're drilling into. So a couple other drill things to talk about. When we're done drilling our screws in or driving our screws, we need to take care of the holes. Generally speaking, we don't want to see any visible fasteners. And we can do that in a couple of ways. One, we can take some wood filler and patch those holes, but it usually doesn't look very good. It usually doesn't turn out very nice. A couple other options would be to use things like the button, the end grain plug, the face grain plug, or a contrasting plug. So the button has a dome shape and actually kind of gives it some contrasting planes there. So it's not just a flat, smooth surface. You can tell that it's supposed to be there. The end grain and the face grain plug are similar. You can see it's just depending on where it's cut from a board. The end grain has a different texture to it, and you can see in there some of the end grains of the material. And the face grain plug actually blends the best, and you can see some of the grain pattern you're able to kind of line up a little bit better. Contrasting plug is an example like this, where we're using a light colored wood like maple, and you're using a dark colored contrasting wood like walnut. And those two would contrast against each other. Or maybe you're using walnut for your base material, and then your plug is going to be maple. It's going to have a contrasting colors while you're working. Now, the way to get these plugs to work is we're going to use this countersink bit here that has this long area here. So we can countersink and have that countersink come down deeper in the wood and have the slot, okay, this long edge here can be created by this depth of this bit here. This is going to give room for that button or one of those end plugs to be glued into this surface and cover up that fastener. And that way it's not going to fall out or come loose on you later on. Those flat walls would accept the round piece of wood. And that's made with this countersink bit that has the pilot hole already in there. You can see there's some room there for that to create that. A couple other fasteners we're going to talk about. This one is called a pop rivet. And how the pop rivet works is usually it's going to be into a material that you don't have the ability to put threads through, and a bolt would be too big. So like if you had two thin pieces of material and threads wouldn't really catch on those two, and a bolt would be too intrusive, then you could use a pop rivet. So you'd put the pop rivet in the hole, you'd put the pop rivet gun on there, and as you started pinching that down, this would start to collapse on itself. And there's a certain point where these would break off, and then that you can see that that stem is gone out of that pop rivet. And that would keep things securely in place. Another fastener that we might use is a dowel, and a dowel or a dowel rod. Now you can see these particular dowels would look different. This one's a solid dowel. This one's got a little spiral, flutes cut in there. This one has kind of a twisted look to these little channels, and this has a straight look. Now what these three on the right do is allow for when you push the dowel into the hole, it doesn't push all of the glue out, right? The glue has channels to stay in, and then there's more surface area for glue, and it's not all pushed out of the hole. This also allows like the air to escape. So as you're pushing something the exact same size as the hole, it's going to want to do something with that air that's in there. It's going to allow it to escape out, and then the glue to start oozing out. Same with this one. The glue could follow these channels, gives you kind of some more glue surface area. And then these ones, very similar as well. So that would be our dowels and other fasteners. If you have any questions on these fasteners, please talk to your instructor. They'll be happy to answer any questions that you may have.